Welcome, young scientists, to an exciting world of SmartClass. Today, we are diving deep into the fascinating world of force and pressure. Do you remember those times when you played with a ball, kicked it, or even tried to stop it? Well, those are some of the everyday experiences that we'll explore to understand why objects slow down, speed up, or change direction. Imagine yourself on a soccer field trying to make a football move. How do you do it? What about making it move faster? Now visualize a goalkeeper trying to stop the ball, a hockey player changing the direction of the puck, or fielders stopping the cricket ball. In all these scenarios, what do you say has been applied to the ball? That's right, a force. But what exactly is a force? And what can it do to objects? Let's unravel this mystery. In science, we call a push or a pull of an object a force. So every time you kick a ball, push a door, or lift something heavy, you're applying a force. To understand forces better, let's identify some actions as pushes or pulls. Take a look at few examples below. Like opening a door, it requires pull action. Opening and shutting a door requires pull and push actions. Moving a loaded cart can require either push or pull actions or both, which gives examples of familiar situations involving the motion of objects. You can even add more situations to this list. In each case, note whether it involves pushing or pulling and record your observation. As you've noticed, each action can be grouped as either a push or a pull, or sometimes even both. This leads us to a crucial realization. To make an object move, we need to push or pull it. Now imagine a man standing behind a stationary car. Does the car move just because he's there? No, it doesn't. But when he starts pushing it, the car begins to move. This shows that forces are a result of interactions between objects. In some situations, it might be a bit tricky to figure out who's pulling and who's pushing. Can you determine who's doing what in these scenarios? Whether it's two girls pushing each other, a cow and a man seemingly pulling each other, or a game of tug of war, forces are always at play when two objects interact. But what happens when two forces act on an object in opposite directions? Does the object stay still? Remember the tug of war example? When two teams pull equally hard, the rope doesn't move in any direction. So, the net force of an object is the difference between the two forces acting on it. Forces can be stronger or weaker, and their strength is expressed by their magnitude. Plus, we must specify the direction in which a force acts, because as you've seen, the direction of the force can change its effect. Now, let's try something fun. Find a heavy object like a table or a box that you can't move on your own. Attempt to push it by yourself. Can you move it? Now ask a friend to help you push it in the same direction. Is it easier now? Finally, push the object while your friend pushes from the opposite side. Observe what happens. Forces are all around us. When you push a ball, kick a football, or lift a heavy bag, you're applying a force. It can be a push or a pull, and it can change the state of motion of an object. Let's take a rubber ball for example. When you gently push it, it starts moving. Push it again while it's moving. Does it change speed? What if you put your hand in front of it? Your hand applies a force to a ball, changing its speed. Forces can make objects speed up or slow down depending on their direction. Think about a soccer match. A player applies force to kick the ball into the goal. If the goalkeeper jumps to stop the ball, the force they apply can change the ball's direction or even stop it completely. It's not just motion. Forces can also change the shape of an object. When you press a lump of dough or squeeze a toothpaste tube, you're applying force to change their shape. Forces can be grouped into two categories: contact forces and non-contact forces. Muscular force is an example of contact force. When you pull a heavy object, your muscles are at work. Non-contact forces include magnetic force. Have you ever seen a magnet attracting metal objects without touching them? That's magnetic force in action. Now let's delve into the concept of pressure. Pressure is a force acting on an area. The smaller the area, the higher the pressure for the same force. Using a sharp knife makes cutting easier because it concentrates the force on a smaller area. That's why broad straps on bags distribute the force, making it easier to carry heavy loads. Liquids and gases also exert pressure. The deeper you go in water, the higher the pressure due to the weight of the water above you. This concept applies to gases as well. Atmospheric pressure. The force of air around us is what keeps things in place. It's why we don't get crushed under its weight. Here's a fun experiment. Take a glass, fill it with water, and cover it with a card. Then flip it upside down. The card holds the water in thanks to atmospheric pressure. Now to recap, forces can be pushes or pulls. Forces are due to interactions between objects. Net force is the difference between forces in opposite directions. Force strength is expressed by magnitude. Force direction affects its effects on an object. Pressure is the force spread over an area. So there you have it, an exciting journey through the world of forces and pressure. Remember, forces are everywhere, and understanding them helps us explain many everyday phenomena. We will meet you in the next video with another interesting topic. Hope you liked the video. Please like, share and subscribe to our channel and click on the bell icon. Till then, keep exploring the world of science. Have a joyful learning experience and stay curious.